Welcome to my video on 1-4 and 1-5, starting with solving equations. Okay, today we're going to be solving literal equations and inequalities. But first I wanted to talk about some special cases when solving just regular equations. So the question says, is this equation always, sometimes, or never true? Now you may not see this when you first look at the page. However, if you're in the process of solving, you may sometimes see some weird situations play out. For example, in this first example, I typically would combine my like terms on the same side. So here I have 3x plus 6 on that side because I combined the 7x and the 4x minus 4x. And here I get 3x plus 4. Okay, so now when I go to combine my like terms or move my x's to the same side, both of my x's will cancel, right? 3x minus 3x end up canceling. And I end up with something like 6x plus 4. 6x is equal to 4. So think about that. Can 6 ever be equal to 4? No, it's a false statement. It's impossible. So that means no matter what value I plugged for x, right? In the end, it will always get canceled. It will not affect this equation, and we will never get anything that's true. Okay, so this equation is never true because when we solved, we got a false statement. So what does this mean in terms of solutions? Well, if something is never true, that means there is no value for which I could plug in for x that makes it true, meaning there are no solutions. Okay, so if at any point you solve something and you get a false statement, you have no solutions to that equation. So similarly, if we solve the next one, right, we get 7x plus 3 equal to 7x plus 3. Hopefully you recognize that both of those are exactly the same. But even if you didn't and you moved the 7x to both sides, right, you still see that 3 is equal to 3. That is a true statement, right? That is always true. No matter what I plug in for x, right, I will always get 3 is equal to 3. Okay, so this is what would be an example of something that is always true. Now, if something is always true, that means that there is infinitely many solutions. Meaning every number you can think of could be plugged in for x and give us a true statement. Now, sometimes is every other equation where we've solved before, right? It's anytime we get an answer, x is equal to a number, okay? Because that equation is only true sometimes when x is equal to that number, all right? So keep in mind that you might see these weird cases from time to time, but it doesn't mean that you did it wrong. It just means that there are some special cases. Okay, so now we're moving on to what's called a literal equation. So a literal equation is just a regular equation, but there are many different variables, okay? And typically in these literal equations, you are not substituting for any of the variables, but instead just identifying one of the variables and solving for it, okay? So how do we do this? Well, we still use algebra, right? We still use our inverses. We still use our reciprocals, our everything that we do with algebra, except that it may not simplify as nicely, okay? So here we have 1/2 BH. The first thing you want to do is get rid of that 1/2, okay? Now, it is multiplying by 1/2, but if you remember from our last lesson that to get rid of fractions, it is more beneficial, right, to multiply by the reciprocal than to divide by the fraction, and that's because it simplifies better. Okay, and I don't have to do the keep, change, flip. It does it for me. So I multiply by 2/1 to cancel that out. And on this side, I just get 2a is equal to bh. So now I have a multiplication. I want to divide by the variable I don't want. So that's h. Leaving 2a over h equal to b. Okay, so did I answer the question? Well, what is b? Yeah, well, I found b by itself. In terms of a and h, well, that's what's on the other side. So I did, all right? So there's no further simplifications that can be done. We just leave our answer in that way. Okay, so let's try another one. Solve for x. We have x over a minus 5 equal to b. Now, typically, you follow the reverse order of PEMDAS, unless there's a special case where you have to find something inside the parentheses, and we'll talk about that in the next example. All right, but here we have just a few things to get rid of. We have to get rid of the 5 and the a to get x by itself. So the first thing I'm going to do is I'm going to add 5 to both sides, okay? Leaving me with x over a is equal to b plus 5, okay? So now I am currently dividing by a, so to get rid of it, I'm going to multiply by a. And I'm multiplying both sides. So it's going to be really important the way in which you represent this, okay? I'm multiplying the entire side by a, so the whole side must be put into parentheses. Now, you could distribute, okay, but it doesn't necessarily make this any simpler. So I could actually leave my answer just like that. A times b plus 5 in a parentheses. Okay. How about number 55? We're still solving for x, but we have a problem, right? Not only do we have 2 different x's in this question, we also have them trapped inside parentheses. Okay, so in this case, we're actually going to distribute across the parentheses first, because that's the only way to get these x's to escape out of the parentheses. So I end up with cx plus 2c minus 5 is equal to bx minus 3b. Okay, so now we got rid of the parentheses issue, but we still have 2 x's. Now, typically in an equation, when it's not a literal equation with a lot of variables, we would move all the x terms to the same side and everything else to the other side. I'm going to do the same thing here. So I'm going to move this bx to this side. Okay, so cx minus bx, 2c minus 5 equals minus 3b. And then I'm going to move over all the terms that don't have an x. So minus 2c and plus 5. Now, again, I just went this way because I typically put my x's on my left-hand side, but you could have went the other way as well. So I end up with cx minus bx equals minus 3b minus 2c plus 5. And now I'm stuck. I struggle with combining like terms here because there's no coefficients, okay? But what I could do here is actually reverse distribute an x. Okay, what does that mean? Well, I know that if I have an x in both these terms, this came from the expression c minus b times x. Okay, so now I've turned this subtraction question into a multiplication question. Are they equivalent? Absolutely. Okay, so you had to be a little bit strategic here. And now how does that help me solve this? Well, next, since it's multiplication, I don't care about the c minus b. I just want the x by itself. So I'm actually going to divide by that parentheses altogether. Okay, canceling those out. Oops. Leaving me with x equals to minus 3b minus 2c plus 5 over c minus b. Now, keep in mind, do you see all of these additions and subtractions? Okay, I cannot cancel any of those b's and c's because of those additions and subtractions, okay? They would need to be multiplication in that denominator especially, okay? And you would need common factors in all the terms in my numerator. So we just leave our answer exactly like that. Sorry. Okay, so that's literal equations. Again, none of the rules of algebra go away. You're just being a little bit more creative with the simplification sometimes. Okay, so 1-5 is the last section we'll talk about today, and that section is talking about inequalities. Remember, something is an inequality if it uses one of these symbols. Okay, and the main difference between inequalities and equations is that with equations there's one answer, but with inequalities there's a range of answers that work. Okay, so first we need to talk about keywords that tell me I have an inequality. Well, of course, if you ever see is less than, is greater than, etc., right? Those tell me I have inequalities. But also, if we read this example, the product of a number and 8 is at least 25. At least is a key word that tells us we have an inequality. Okay, and what does that mean? If I have at least 25, that means I have 25, but I also could have 26, 27, 28, anything bigger than that. Okay, so 8 and times a number, right? Product tells me times. It has to be bigger than or greater than or equal to the number 25. Okay, so at least tells me that. Whereas in this part, at most, right, if the product of a number and 8 is at most 25, that means 25 is the biggest number that it can be, meaning that it has to be less than or equal to 25. Some other phrases that tell me I have inequalities: a maximum of, a minimum of, etc. So just keep those phrases in your brain because they hint towards solving inequalities. Okay, so now how do I solve these inequalities? There's no difference between the algebra with solving equations and the algebra with solving inequalities, except when I multiply or divide by a negative number on both sides of my inequality symbol, I flip the symbol. So I will show you an example of that. But again, not every question is going to need that. So you need to make sure you're paying extra close attention. So here we have 2 outside of a parentheses. With regular equations, I would distribute. So I'm still going to distribute here. Okay. I have like terms on the same side. So I'm still going to combine those to get +1. I still want to isolate my m. So I'm still going to move this over. All right. So really, it's only at this step that you need to really pause. Okay. Pause and look at it. Do I have to divide or multiply by a negative number on both sides? The answer is no. So I'm still going to use my inverse, and I'm not going to change my sign. Okay, so I get my answer as m is less than 10. So how do I graph that on my number line? Well, first I have to identify where 10 is, right? And here I'm going to leave what's called an open circle. An open circle is a circle that's not shaded in. Okay, and it's an open circle because there is no or equal to. It is not included in our solutions. All right, so we leave that circle open. And we want all the m's that are less than 10. So that's everything going in this direction. Okay, so that's how we would graph the solution. And that means that all of these are solutions, right? -9, -8, -6, -1, 2, 5, 6, 9, all the way to 9.999, but not 10. Okay, 10 is not included. So solve and graph this. Again, we're working with the same algebra. So I still distribute. I get this, right? I still have like terms. And I get, what, -13, greater than or equal to 3. I still add the 13 to both sides. But here's where I have to pause, okay? Do I have to multiply or divide by a negative number? And the answer here is yes, right? If I have times -2, I have to divide by -2, which means my inequality symbol is going to flip from greater than or equal to less than or equal to, and leaving everything else on the other side. So now I have the answer, x is less than or equal to -8, meaning I go to where -8 is, and this time I have what's called a closed circle, meaning it is shaded in, okay? And that means -8 is included in the answer key, okay? We could substitute -8 and get a true statement. And we want all the x's less than it, and that goes in that direction. Make sure you include your arrowheads. Okay? So what is the golden rule of inequalities? Well, we just said it. If you divide or multiply by a negative number on both sides, right, as an inverse, flip your sign. Yeah, let's say inequality symbol. Okay, now the reason I mentioned multiply is for examples like this. -2/3 x is greater than, is less than 6. Right? Remember how I said in the last lesson, we could cancel out this -3 by multiplying by the reciprocal. Okay, so I'm multiplying by negative 3 over 2 on both sides. Well, I am multiplying by a negative, which will flip my sign. And everything else gets canceled in the same way. Okay, so divide or multiply. Other rules, open circle is that, means not included. Right? It's not shaded, and it is used for strict inequalities, strictly less than, strictly greater than. Closed circle means it's shaded in. That means that value is included. And it is used when we have greater than or equal to or less than or equal to. Okay? So I'm going to ask that you attempt these practice problems. Number 59 is a challenge problem. Don't worry so much about that unless you're in my honor section. But the first set of questions are from 1-4, and the second set of questions are from 1-5.